G'day. I think this might be near the end of my solar shared project. So in this one, I just need to be able to work out a way to get sound to and from my rig when I'm running it remotely. Looking around, I think I'm going to be using Mumble, and I'll run through how I set that up on my Raspberry Pi and the various things I need to set up to get the clients talking to the micro SDX transceiver and then back to my remote client. So let's dive in, have a look. So here's my architecture, or my proposed architecture. Like I said, I'm going to be using the Mumble to get audio to and from my remote PC and down to my micro SDX transceiver. So just working from the remote side of things, I'm going to have a remote Mumble client, and that's going to be the thing that connects to my microphone and the speaker and sends audio to and from the Raspberry Pi and down to the micro SDX over port 64738, which is a standard Mumble server port. So on the Raspberry Pi, I'm going to need to set up a Mumble server and a Mumble client, and again the client on the Raspberry Pi connects through the same port to the Mumble server, so there's a shared session going on between the two clients. So they can send audio to and from each other. And then on the Mumble client, I think that needs to go via a PulseAudio driver to the ALSA sound infrastructure running on the Raspberry Pi, and that's going to connect via USB port to the USB sound card, which has the typical line in and line out connections. I'm going to need to put some sort of interface between that and the transceiver, so I think I'm going to use some audio transformers just to isolate the two devices, and then I'm going to need some sort of volume control because the mic at each end is a lot more sensitive than what the various speakers are putting out, so I need to reduce the power coming through those somehow. So that's the proposal at the moment, so let's get into the individual stages and see how well this works in the end. Okay, let's install Mumble server on my Raspberry Pi. Just to let you know, this is the second time I've done the install. I removed it, so a lot of the dependencies are already installed in this case. Now we can configure Mumble server. That's pretty easy to do. We just run the dpg reconfigure for Mumble server. It's going to ask whether you want the service booted up and restarted. Yes. We'll give Mumble server a higher priority. In theory, that should allow it to have less glitches in the audio streaming. And we need a password if we use the super user account. I'm not planning on using it for this application, but I'll still put in a password. I'll just use my call sign. Yeah, that's good. Now let's go into this etc Mumble server ini file and do any additional configuration in there. I'm just going to use nano to configure the ini file. Because I don't think I have many changes to do. I may not have any to do, but I'm going to zap down here to server password. I'm actually going to take that out. I'm just going to have no server password because this is all running in my local network. And my welcome message looks okay. I updated it before, so that's all good. So I'm going to restart the Mumble server just to make sure it takes the new ini parameters. It's good. So I'm going to install PulseAudio as the interface between Mumble and the actual lower level USB sound drivers. I'm going to install the Mumble client. So I've got the Mumble server and the Mumble client installed on the Raspberry Pi, so I'm going to test out the client to make sure it can connect to the server. So when this fires up, this talks through Xwindows through some GUI screens. We can see them here. And we can see here it's asking to connect, and it can see my Raspberry Pi 3 that has the Mumble server on. So let me just select that, connect to it. It's going to ask for a username for my client, and I'm just going to call the client Raspberry Pi 3 as well, since it's running on the Raspberry Pi 3. It's connecting. Again, because I left the password blank, it doesn't ask me for a password, which is good. And you can see here I'm connected to the server that I set up there. That's the welcome message that we saw set up on the server. And here we can see what's connected to the server at the moment. It's just my Raspberry Pi 3. So next test, I'm going to get another machine running Mumble and connect that in as a client and make sure audio goes backwards and forward between the two of them. So I'm over on my Windows development box, and here we can see the server status shown from the Raspberry Pi 3, and still just got the Pi 3 client connected to the Mumble server. So let me fire up Mumble on Windows, and you can just do a simple Windows install to connect up. And so it's asking what I want to connect to from the Windows side, and this time I'm going to connect as Windows, because I can't think of a better name for my client. Connected. So now we see we're connected, and you can actually hear my audio being picked up and played on the Raspberry Pi audio. So we've got a good connection going here, and we see the two clients. So that's going well. So one problem, let me stop this.
Disconnected from server.
So one problem with this is on the Raspberry Pi client, it's firing up a GUI, so I'm going to have to make that run headless. And then another problem I've got, you probably saw it earlier, was with output from the Mumble client is putting out these warning messages all the time, which I don't want, and it actually is a performance problem. It's drowning the SD card on the Raspberry Pi with a lot of logging, so I want to send that somewhere where it doesn't appear. So here we are back at my architecture diagram. So this is the Mumble client here that runs on the Raspberry Pi. So I'm going to get my Solar UI to fire that up the same way it fires up some other things. But I want it to fire up headless, so I don't want any interaction with this. So you can fire up Mumble with some command line options to connect automatically to a certain server. So I'll show you how I do that. The other thing is this Mumble client always expects to talk through Xwindows, put up those GUI programs where you go through the connection process, so it shows the server status. Because I'm in headless mode, I don't want that. So there is a utility out there called xvfb, which is a Xwindows server. I think it's used for testing, but it basically consumes Xwindows streams and doesn't display anything. So that's just what I want. So I'm going to have this Mumble client fire up and talk to this xvfb Xwindows system. So basically do nothing. So I'm going to install the xvfb utility. This will be a Xwindows, it's kind of a dummy frame buffer, but it'll allow me to run the Mumble client headless. Now I want to run xvfb as a service. So basically I set up a service file, so we can have a look here at the file I set up. So it's under etc. systemd system xvfb.service, and we can see here it's just a service definition. This is the important bit, the exec start. It runs xvfb, sets up display number 99, and I set it up so it always restarts, always starts when the Raspberry Pi starts up, so that's good. Okay, now I just need to enable that service and start the service, and I can pretty much forget about it now. It means xvfb will always be running in the background as a service. Let me see if I can show you how the headless version of this all works. So over here you see Mumble client running on Windows. So at the moment I see only the Windows client connected to my Mumble server. Over here is the Raspberry Pi. So the first thing we need to do is set the display output. So this is going to make the Xwindows output from the Mumble client on the Raspberry Pi basically disappear. It's going to go into xvfb. And now let's run this command here. So this is the command that's going to run Mumble basically headless. So I'm going to use no hup or no hang up. So this means that the program will continue running even if the session ends. Then I tell it to run Mumble, and then I give it this Mumble parameter. So this is the parameters for connecting to the server. So again, it can be done headless. So this is the name of the client, Pi3 in this case, and then this is the name of the username of the client, Pi3, no password, and then what server it connects to. So my server address is rpi3.home. This part here basically sends the standard out from the Mumble client into the ether, goes to dev null, so it doesn't go anywhere, which is good. And then the and sign makes this whole thing run in the background. So let's try running this. So no hup has told me it's fired up this process here, and now we see the rpi3 client is connected, and you can also hear in the background maybe the output from my microphones now also going over to the rpi3. So everything's working, and this is happily running in the background. So just showing I documented this all into this rpi setup markup file here. The link to that's down below, but you can see here I've described basically what we just went through. So the Mumble setup, installing the Mumble server, configuring the Mumble server, edit the ini file for the Mumble server, and my main change was to remove the password so it's easier for clients to sign in, and then restart the Mumble server. Then for installing the Mumble client, first I install PulseAudio just because that seems to be a better interface for Mumble to work with. I do the install of xvfb, I set up a service definition for xvfb so it can just run in the background and start when the Raspberry Pi starts up. Then I enable that service, start that service, then finally install the Mumble client if I haven't done it already. And here I've got some notes about how you run this. Now, this won't actually be run manually, so what I'm going to be doing is in my Solar web service where I'm starting the rig, I'm also going to go through these steps of setting the display, firing up the Mumble client so that's running when the rig's started up and I can connect to it. And then when the rig's closed down, I'll just do the opposite. I'll re-export the display to where I normally want it to go, and I'll find the Mumble process and kill it. And that seems to close it down cleanly. So once all my Mumble stuff was set up on the Raspberry Pi, I just need to put the web services in to be able to turn the Mumble client on and off on the Raspberry Pi, so it was connecting into the micro SDX transceiver. So the way I did that in the Solar UI or the Angular web application, I added a new service which calls the rig service, and in the rig service I've now added another call in the rig on, which is part of solar relay.py, which calls a subservice called Mumble on, which basically turns on the Mumble client on the Raspberry Pi, so it all gets switched on. So the whole point of that is when I turn the rig on, it also is turning on the Mumble client on the Raspberry Pi so that I can connect via Mumble to the audio in and out on my transceiver. So let's have a look at the code. It'll show you a bit more detail about how these things hang together. So this is the actual code that I have. So in my Flask service, so this is the one that gets called from Angular across the network. So I added to the rig, I didn't actually have to make any changes to the rig service here. So the rig service is calling the Solar Relay rig on service. So let's have a look at that one. So here's the rig on service. So before it was just turning the power on to the transceiver, but now once the power is turned on to the transceiver, I'm also calling this Mumble on function here, and Mumble on's up here, I think. Okay, Mumble on. So in addition to turning, once the transceiver is actually powered up, then it goes and calls the Mumble on, and here's that I'm calling the OS function sending this request to the system, which is basically a command line that we saw earlier for firing up Mumble or the Mumble client in a headless mode. So it's setting the display to display 99, so it's using that pseudo Xwindows display for setting the Xwindows stuff to, and then using no hup to fire up Mumble, passing the Mumble parameters for what Mumble service I want to connect to, and then just sending the output standard out from the Mumble client into the ether to this dev null so it disappears, and running the whole thing with the and sign at the end so it runs in the background. And that's how the Mumble client gets fired up after the rig gets powered on. And then I've got the same sort of thing for turning the Mumble client off here and resetting the display setting. Okay, here's what the whole thing looks like when I've got it running. So I've got my Mumble client running on my Windows machine here. So this is basically when I'm using the transceiver. When I'm on a remote machine, I can just run the Mumble client like this and be connected up to the Raspberry Pi. And then that new code I put in is under the rig. So I do a rig on now. And that turns on the rig. And it also fired up the Mumble client. and there's a bit of a delay there while the Mumble client fires up on the Raspberry Pi, but now you see here the rig is now connected to the Mumble service that's running, so Windows and the rig are both connected now, so I should be able to do things like, here I am in 10 meter band, I should be able to turn push to talk on and send audio to the transceiver, which will then transmit on the 10 meter band, whichever one I'm on at the moment. And you can kind of hear in the background too the sound being received on the rig. Okay, testing Mumble and the SDR radio and everything else got fairly complicated. So I'll just show you what my test setup looked like. I won't go into it in details, but basically I was running Mumble as a client on my Windows machine, my development machine. And here you can see the user interface on Windows for Mumble. And then Mumble on Windows was getting its input from the microphone I have next to my desktop, and as well as just talking into it and seeing what it looked like when it got over to the Raspberry Pi. I was using an audio oscillator as well, so I could send sine waves through the microphone and see what sort of quality they were when they were arriving at the other end. So there's Mumble is going through my network over to the Raspberry Pi, which has the Mumble server on it, and also has the Mumble client that's connected to my micro SDX transceiver. It's connected to that via this USB sound card here, and that goes through an audio interface. So I spent quite a bit of time tuning this up. So it's got a couple of audio transformers and variable resistors to match signal levels needed by the microphones and things. So I'm getting the mic going in through the front panel mic connection, and this output from the SDR radio is coming from the connector on the back of it, and they both go through the USB sound card. On the SDR radio I had that tuned to the 10 meter band because that's the only thing I can send audio over at the moment, and I've got a I've got a 10 meter aerial connected up to that, and that would send the output that the radio was hearing back over here where I'm using software defined radio, this little thing here. It's like a little USB connector that's connected up to an aerial, so the micro SDX radio was transmitting on 10 meters over to this receiver. This SDR receiver was receiving it, and then I was using this SDR radio receiver software to tune to the 10 meter band so I could see the sound coming in. So in theory I should be able to have sound going via Mumble through my microphone over to the radio, have the radio transmit it back over here, and have it appear back on my SDR radio here. And I can sort of hear what the quality is like there, which was kind of the whole point of this thing, was to be able to play with the potentiometers on this interface and make sure that I was getting the levels right without blowing out sound levels and getting a high enough volume that this radio could send a decent signal. So I'm about ready to move everything out into the shed. So here you see the test setup. So the audio interface I'm going to put onto the Raspberry Pi shield that I have out on the Raspberry Pi in the shed. So move those transformers and the potentiometers up there. Connect it all up. But I think that's about it for this video. So I've got one more video to do, so I'll just show you everything when it's connected up in the shed. I'll have the aerial moved out there, and we'll do a test run to make sure I can transmit and receive on the radio.